Where were you seeing?
So, here's the difference between growth and decay and compound interest. So the formulas look very similar. Instead of an A value, which if you remember when we were doing this yesterday, our A value, guys, A value is like the starting amount. Here our starting amount is what we call principal. The reason it's got a different name is because, like, if you ever go to get a loan or you have a savings account, your principal is the amount of money that you put down. So if I go to get a savings account and I put $5,000 in the savings account, that's my starting amount. That's what we call our principal. R is still going to be the same thing that it was when we were talking about growth and decay. It's an interest rate. We still have to divide by 100. T is still time, so we still have time, and you'll notice T is in the same spot, but there's one thing that's different, and I haven't highlighted it yet. It's N, which is this ugly schmuck right here. So, here's the thing. When you go to get savings accounts or you apply for a loan, do you think banks are going to be really, really honest with you about all of the details? Banks low-key rely on you not knowing stuff. They also use big words to confuse you. Like you'll notice here, N is the number of compounds per year. Compounds is just another word for collect. So it's the number of times that your interest collects during the year. You would think that like interest collects once a month when you pay it, but some loans and some savings accounts compound interest more frequently or less frequently. And again, if I told you a 5% rate that's compounded monthly versus yearly, you really don't know if, like, what tangible difference that is in money. Do you guys care about money? Yeah, so like when you walk into a bank, you don't want to be like oblivious to what's going on, or like the very worst thing is when you go to buy a car, you know how many people don't know anything about buying cars that walk into car dealerships and just immediately tell the car salesman exactly what they want to hear? Like, the whole goal of this unit is A, so that we're like a little bit more prudent with the things that we know about like money, because like unfortunately money is going to control a lot of what we do. Now, before I move on, this N is going to be in the problem. So like you're always going to be looking for the word that says compound. So like when we look at these word problems, you're going to notice it says compounds monthly or compounds yearly. Guys, N is just the number of times that that thing happens in a year. So for instance, if I say if it compounds monthly, that's how many months are in a year? 12. So my N value, and it says monthly, is going to be 12. If it says it compounds annually, annually means it happens once a year. So my N would be 1. If I say that it compounds weekly, which means every week it's collecting interest, that means that my N value in my formula is going to have to be 52. Because there's 52 weeks in a year. We're also going to, like, we're not going to make fun of anybody, but today I was like, oh, how many months or how many weeks are in a year? And somebody said 7 because you're thinking like there's 7 days in a week. We're always talking about the number of those in a calendar year, because your interest is always based off of a year. Now, I'm going to kind of skip over the steps because we're going to go over them together. If you need the steps as we're going, you obviously have them. We're just going to jump right into example 1. Boom. Now, it's going to kind of follow the same process that the other problems did with growth and decay. We're going to have to read the question. We're going to have to underline and mark up our points that we have to plug into our formula. I'm going to put the formula right here. P1 plus. Now also, do you see on the growth and decay formula, this was only a t in the exponent? Mm-hmm. But this is nt. This is just n times t. These two things are being multiplied. Mm-hmm. So, when we read the problem, it says you put $12,000 into a account that has annual interest rate 9.275%. So, this seems important, right? Yep. What is this? Yeah, it's going to be the P. So my P is going to be 12,000. Principal is always what you start with. Starting off. I'm going to keep reading. Annual interest rate of 9.275%. Now also, low-key, the thing that happens every year is you see annual interest rate and you think that your N is going to be 1, but it's what follows the word compounds. All interest is yearly. but the way it's collected or compounded might be different depending on like what amount of time. So here, my interest rate, which is R, what do we gotta do with it? Yeah, don't forget to divide by 100, or you can just like slide the decimal over 2 spaces if you prefer that. Then we gotta find N.
Use the 12 months.
Yep, the account compounds monthly. So that means that it's gonna be compounding interest 12 times a year, once a month, there's 12 months in a year, so my N's gonna be 12. When I say literally the only difference in this is like you have to find your N value, it's the same as growth and decay. But like then when you plug it into the formula, you have to remember to put it in the 2 spots where it's located at. And then T, 10 years. Now, side note, do you think that you could just put money into a savings account and live off the interest and never have a job ever?
No.
With an asterisk, I'm gonna say no. Like if you're like I've ever heard of like a trust fund baby that parents just have a ton of money in a big account. To make a lot of money off of the savings account, guess what? You gotta put a lot into it. A lot of money. So we're putting $12,000 in it. That seems like a reasonable amount. We're gonna see how much is left after 10 years. So we're just gonna plug 12,000, 0.09275, 12, and 10 into our formula, which I'm gonna do over here. Also, please, when I say please practice this in the calculator, the hardest part of this is literally reading it and typing it into the calculator. If you can't type into the calculator, like, you're not going to be able to do it. So, we got our interest rate, 0.09275. We got to divide by our N value, which is 12.
That's a very great question.
What's that?
Do you have to put the
2 numbers there or 1?
no, the 9 or 20?
You don't have to put it in parentheses. So how did I get 12? Remember this says compounds monthly. So monthly means bottom. Now pause. Do you want to learn the easy way or the hard way?
Easy.
So like the hard way, and guys, it's not hard. Do you notice how my exponent in my formula is NT? You can technically watch, you could write 12 times 10 up there, but what I always do is I just multiply the numbers and write that number up there. So instead of writing 12 times 10, I'm going to write 120. The reason I'm advising to do that is if you don't, like sometimes entering it into the calculator, if you have to enter in a bunch of operations, sometimes you might be like driving the struggle bus because you typed something in the calculator wrong. So at this point, we got everything plugged in. Do we have any issues with why stuff isn't where it's at? I tried to color coordinate all nice and pretty.
You know I'm gonna delete it, are you?
Yeah, I'm going to delete the
Wait,
whole thing.
no, you're not. Here.
So I'm going to type it in. 12,000. Oops, if my calculator wants to work. Parentheses. Today, one of the biggest mistakes, I have kids, I'm not getting the same thing. A bunch of people have been forgetting the 1 plus part of the formula. That's just like in there, so don't forget that. I don't know why people forget it. If I had the answer, they wouldn't. Divided by 12. Now, Rich asked, you probably didn't hear him, he said, do I have to put this in parentheses? You guys just straight up type it in. You don't have to do extra parentheses. You just need the one set that's part of the formula, and then I gotta raise this to the exponent. You can write 12 times 10 up there, but I just rather write, like, do 12 times 10 and write 120 because it's easier. So when I hit enter, are you getting this? Try it. Of course. Now also, if you know how to type in growth and decay, it's essentially the same thing. But like I said, you got to be careful because you're going to have an N value here. When we did growth and decay, the N was there, it was just a 1. Now it changes because interest is compounded at different rates. So this means that this $12,000 that sat in his bank account ended up being $30,230. Anybody want to take a guess at how I'm going to round this since it's money? How many decimal points? 2? I think when you go to the store and you get change, there's only 2 numbers after the decimal, right? So after the 7 is a 5. 5 and above, give it a shove. So I'm gonna make this 0.18. Now, in 10 years, think about how much money that account made.
20,000.
Almost 20,000. We went from 12 to $30,230. So just a little bit over $18,000, which is nice. But guys, think about that in a 10-year period. Is that enough to live off of?
No.
I mean, I don't know what your quality of life is, but I don't think I could live off of like $18,000 for 10 years. That would be crazy. Now, am I telling you that you shouldn't invest in a savings account? No, I just don't want you to get this like facade or this weird idea that like, oh, I'm just gonna put money in the bank and live off of it. I mean, this is nice. I would like to put my money in the bank and like literally almost multiply it by 3 in 10 years. Imagine if instead of putting $12,000 in the account, they put like 30. You can see that like as you put more money, the amount of money you make back is gonna be even.
So basically just be a millionaire.
Yeah, but to get $1 million from savings, you have to like, you almost have to be a millionaire ahead of time, you know what I'm saying? So, when I say that's about it, we're gonna do a problem where we compare two accounts, which is like, I think like number 4 or 5. And the whole goal of this is next week, you are literally going to shop for a car online. I'm gonna have you guys bring your Chromebooks in, you're going to find a car that you would wanna buy. Like legitimately something that you would want. One of the days we're gonna spend time finding interest rates online, and we're actually going to calculate how much the car loan would cost. So,
It's gotta be brand new.
it doesn't have to be brand new. You can buy a used car. So if you want to buy a car that's $10,000, $5,000, that's fine. It doesn't have to be brand new.
Does it have to work?
We'll talk. I've never had anybody ask me. Alright, anyways. A car is a car. Well, if it doesn't work, then all you can really do is in it is sleep, and I don't really want to sleep in the car, so.
I do.
Are you going to fix the car?
Does it have to have like a working like engine or something?
Yes. Anyways, example 2. Now, like I said, guys, this is not just, this is not just for savings accounts. Anything dealing with interest compound interest is directly related to principal, rate, time, and then your end value is how often it's collecting or building interest.
Who's gonna get the hot dog?
We're not talking about Oscar Mayer. When you were born, your parents put $5,000 into an interest building account.
No, for it.
That seems important. I'm gonna circle it.
No.
The interest building account compounds. Yes, guys, keyword. Also, wouldn't it be a lot easier if banks just said collects interest rather than compounds? When I'm trying to set up the stage where you're realizing that sometimes the banks try to talk over your head a little bit and hope that you don't know what's going on. Now, I'm not telling you that banks are all sleazy, but banks are in the business to make what? Money. Also, not to get sidetracked, do you know how banks make money off of your savings account? Yes. Guys, you don't pay the bank for your keeping your money. You give them your money, but what they do is they take everybody's money and they invest in stocks. So they basically take your money and invest in it because you're not.
Is that why there was a person?
Kind of. We're not gonna get too sidetracked. What happens, guys? They borrow your money, borrow it, and then invest in all of these different things. They make money, and then when you need yours, they just pull it out of the investments, and they're like, "Oh yeah, it's right here." Side note: do you also know that no bank around anywhere has more than $10,000 in the bank at a time? Some people didn't know that. If they kept a lot of money in banks, what would happen?
Would get robbed.
Yeah, so aside from the whole die on the bills and the little button under the counter, banks don't keep a lot of money. If you went to the bank and you're like, I want to withdraw all my money, and say it was $25,000, they would literally tell you to come back in 3 to 5 days. Because they have to call the Federal Reserve or whoever's in charge of distributing it to physically bring it to them. Because again, they don't hold, it's not like they have a big storage container of everybody's money. They take the money and they do stuff with it. So they don't physically have, if Finn's got $8,000 in the bank, there's not a little lockbox with $8,000.
That's kind of scary though, because what if they lose all the money?
That's why the big money. Anyways, compounds daily. So first off, if we start labeling our stuff now that we got sidetracked. What's up? What? No, it's okay. And that compounds daily, 365, because there's 365 days in the year. Holy crap. We're not going to talk about leap years. Don't even try it. What is a leap year? How are you supposed to know how many days are in the year? I had a senior last year that told me there were 13 months in the year. So, like, I'm not putting anything by anybody. Week 52.
I think he was being funny.
They were for real because after they got like very embarrassed and stormed out. It was not a good time. So they do it in if we keep reading, write the function that determines how much money will be in the account after 2 years. If college costs $35,000, will you have enough to be able to afford it in 18 years? Well, first off, I see 18 years. That tells me my time. 18. And then I just missed my R. 7.125.
Why aren't you highlighting that?
Great question. Did anybody hear what Jasmine said about why didn't I highlight it?
No, talk louder. Please.
Anyways, I will let it go for her. She said, why didn't I do anything with this 35,000? A lot of you guys, when we do these problems that are like comparisons, you're going to want to say that this is your principal. But remember, it's how much you start with. Did I start with 35,000? I'm trying to get that. So this is going to be the number that I compare my answer to see, did I save enough money? Also, I want you to think, like if you were putting money in an account for your kid for college, wouldn't you want to make sure you're saving enough if you were realistically trying to pay for it all? Like imagine not knowing what you were doing, investing money, and then in 18 years you realize you didn't save enough. It would kind of stink. Our formula, we're going to plug this stuff in. 5,000. 1 plus. Here we got our interest rate, 0.07125. Divided by n, which is 18. Oh wait, 365. Whoops. Careful. So guys, remember n is 365. I almost put the wrong thing in the wrong spot. And then n times t is the exponent. Again, I have to multiply 365 times 18. I'm going to do that in the calculator, and then I'm going to write that as my exponent, because n times t is always the exponent. So, 365 times 18. Yeah, 365 times 18 in my calculator, 6,570. So that is my exponent. So, guess what I do now? Are you confused? Are you confused by the 6570 as the exponent? Remember I just did n times t?
Oh.
What's up?
No, it's not. You skipped it.
And I also realized that
It's 2:30.
Now listen, type this into the calculator. Practice typing it in. If you can't type it in, your project's going to be really tough next week because you're going to have to do it a whole bunch. What's up?
Can I go to the bathroom?
Yes, it's best.
Do you have?
I have paper towels over there by the construction. Boom. So here we go. 5 grand times 1 plus my interest rate divided by 365. Throw that up to the power of 6,570.
What's my number?
6,570 was the exponent. So, is this kid getting their college paid for completely?
Yeah.
How much was the college?
35,000.
Is that more than 35,000?
9.
I wish that said 180,000, but it's $18,025. So this family who thought they were doing something. Well, imagine saving money for college and then you realize you undersaved. Right? Guys, planning is key. You don't want to walk into a bank, a car dealership with like no idea because like they can smell blood in the water and they know when you don't know what you're talking about. Or like even when they're talking to you about all of the little details, they kind of match what they say to like what you know. They're not gonna like lowball you if you actually have an idea about interest rates and how to calculate these kinds of things. So will they have enough money? I'm going to community college.
That's cool.
There's nothing wrong with community college. It was more expensive. $18,000 is still a lot of money. So in 18 years, we went from 5,000 to just over 18,000. Also, do you guys know interest rates kind of are bad right now?
Not really.
Because the economy is kind of like,
It's because the presidency.
I don't know if it has anything to do with the president. I don't think it does, but I don't know enough to say one way or the other. We're skipping example 3 because like it just got cut off on the print. So we're going right to 4. Look at that. We're flying through. Now, I've got to give myself a little more room here because if you read this question, guys, there's multiple parts to it. What's up? Over there. We got notes to do, bro.
Yeah.
Okay. So example 4. Sorry, I had to give myself a little bit more space. Now here's the other thing. Talking about being a smart shopper. If you want to buy something, do you just walk into one store, see it, buy it? It's okay. Yeah. As you get older, when you make big purchases, like if you're putting money in a savings account, or you're buying a house, or you're buying a car, you probably shouldn't go with just like the first rate or the first bank you talk to. You should probably like shop around a little bit. This says you want to invest $7,500 into an interest account. Account A compounds weekly at 6.125. Account B is daily at 5.975. So here's the problem. If I told you guys the two differences, you don't know how much the daily and weekly is going to affect how much interest this is going to build. If we're talking about interest for a savings account, we want as much interest as possible because interest to us in a savings account is us making money. So I'm going to have to calculate how much the account is going to be worth for account A if I put my money with the first bank. And then I'm going to have to calculate how much I'm going to make if I put my money with bank B or account B. Now, if you don't like this problem, literally next week we're going to have a project where you're going to have to pick 3 different banks. You're literally going to, I have all the information. Listen, Rich. I'm going to give you like links to banks and you're going to shop for rates on cars and we're going to compare the cost because also, aside from the amount, like the interest rates, when you finance a car, you can pick to pay it for 4 years, for 5 years, for 6 years, and it drastically affects like how much is coming out of your pocket each month. So, here's the deal. When we're comparing 2 things, the amount of money that I put in both accounts is going to be exactly the same. So my principal, I want to invest $7,500. The other thing that's not going to change between the 2 accounts is going to be how much time I would let it sit there. So like both of these accounts, I want to determine which one has a bet is better for me, which one's going to make me more money after 12 years. So I realistically want to compare that amount of money for 12 years in both accounts. But the thing that's going to be different when you go to a bank is going to be your interest rate. And then the other thing is how often it compounds interest. So I'm going to have different R's and different N's for both banks. So, account A compounds weekly. How many weeks are in a year? 52. N always follows the word compound. So you see account A compounds weekly. That's why we got that 52. And the annual interest rate is at 6%. So remember, we just got to divide that bad boy by 100. Boom. Now, obviously, like, if you walk into two different banks and ask for a savings account, they're not going to give you the exact same thing. Also, if you walk into Chase Bank and say, like, is this the best savings account I can get, what do you think they're going to tell you?
Yep.
Definitely. This is the best. You're not going to make any more money anywhere else. They want your money. So, account B compounds daily, which means it collects interest every day, which means my end's got to be 365, and now my interest rate, though, on the daily one is 5.975%. My smart board pen is dying. That's a 9, in case anybody was
So it looks like an
I know. I also am recording the video, so when I say, oh, that's a 9, nobody actually knows what I'm saying if you're watching the video. So. And now, guess what we get to do twice? You just have to do the formula for both of them and compare which one has more. Now, also, if you're like, I don't want to do this in real life, do you guys know what actually exists? Do you know there are calculators that will, if you Google interest calculator, there are literally calculators where you can crank in the numbers and it'll tell you how much it is. So, like, aside from me teaching you, I don't necessarily in your real life expect you to do the, like, work by hand, but at least you would have, like, the wherewithal and the knowledge to, like, go and check, to type numbers in online to see, like, should I go with this car loan or this car loan? Should I put my money in this savings account versus this one?
But we not go
Oh yeah, I'm not. We're not even close. I'm gonna plug all this stuff in. So plugging it into my formula, my principal times 1 plus my interest rate, 0.06125, divided by my n, and then our exponent is always n times t, which I don't want to do 52 times 12, is it like 640? Someone check it, do 52 times 12 in the calculator.
52 times 12?
Yeah.
It was 624.
624? Just off. So n times t, boom. 52 times 12, boom. They're just old. The other one, I'm going to plug the same amount of information in, but again, my rate and my n is going to be different. 1 plus 0.05975 divided by n. So the nt, 365 times 12, that is a really big number. 365 times 12. So my exponent for account B is going to be kind of big because n times t, 365 times 12, 4,380. And then now this just turns into type them in your calculator, see which one makes you more money. Because we want savings accounts, we want the higher amount. If we were talking about car loans, I wouldn't want the higher amount. Which one would I want? Lower. Because if I'm paying it, I want the lower amount. If it's interest coming back to me, we want more. So typing this guy in 7,500, 1 plus, don't remember the interest rate, 0.06125, 0.06125 divided by 52, all of that should have 624.
Getting 6.
So account A, guys, in how many years was it? 12 years, your account went from 7,500 to 15,000. Imagine in 12 years if you just doubled your money for nothing. And when I say nothing, I mean like having it sit in the bank. But like if you already have the money and it's already going to sit in the bank, imagine making double your money in 12 years just by letting it sit there. So account A, 15634, 15634. And again, round to 2 decimal place, hundredths place, 0.35. Now we gotta do account B. 7,500 1 plus 0.0575 divided by 365. Throw that to the 4,380. Okay, where are we at? Are we with A or B? What are we doing? Where are we going? So guys, this is the amount that account A is going to make you in 12 years. This is the account B's amount that it's going to make you. Which one is more? A. Yeah, it's like $300 more. Now, I know $300 over 12 years doesn't seem like a lot, but why would you turn down an extra $300 just because you were lazy and didn't want to check interest rates? Again, little things can make the difference. So this one's 15361 .19? So, if you're like financially literate, you would definitely choose account A because it's just like worth more money. Obviously, we want to pick what's worth more money. Now, I also don't want you to think, obviously the interest rate was higher. Just because the interest rate is higher doesn't mean it's going to make you more money. It depends on how often it's compounded and collected every year. Okay.
I have a question. I could ask this one. This one's it's not.
We're not actually going to do that, so don't worry about it. Alright, one sec. I'm going to just...
I'm past that.
The next one.
Well, stop asking questions.
That one either.
Rich, just wait 1 minute, okay? Oops. Now, what I want you to do, we've got 10 minutes in class. In like 6 minutes, I'm going to put up the answer to example 5. Guess what you do in the next 5 minutes?
Do it.
Hey, guess what you're going to do? Try this. I'm going to put the answer up here. The one thing I'm going to do, though, is remember, the amount you start with is always your principal. You see, this one says your family wants to invest $9,300 for your 10th birthday. That means that that's the amount, your principal, that's how much your parents are going to be investing. If you see this $16,000, that's like the college problem where you were comparing it to something. I wanted to see if my account had enough money to pay off my kid's college. Just like here, your parents want to see if that $9,300 in this account will be enough to pay for a $16,000 car. So your P is going to be your $9,300. Your interest rates, you have 2 of them because you are comparing 2 different accounts.
Different rates too.
2 rates. Your N is going to be different because like one of the N values is semi-annually, and then the other one is daily. Those are going to be your N values. And then the other thing that's going to be the same is going to be T. Which I want you to think, yes, which already gave it away. If your parents are putting money in an account when you're 10 and pulling it out when you're 16, that's 6 years of time. So your T is going to be 6. Principal, always the same for both, but you are going to have to do it separately. One's going to have a different interest rate than the other, and also a different amount of compounds in a year. Give it a go. I'm going to give you 4 or 5 minutes. We'll put the answer up on the board.
But what does that mean?
Semi-annually
What does
means...
the N stand for? 2 times?
Yeah, because annually means 1, semi, like I want you to think a semicircle is a half of a circle. So semi-annually means it happens every half year.
So, right, you divide.
So it's 2.
Yeah.
They could also say bi-yearly, but they just say
Did you put
semi.
the decimal point 5?
You remember when I was talking about the words that the banks use to confuse you? It's just like those things where you get a bunch of words and interest rates in your head, it's hard to like really know what's going on unless you like.
I have 2 questions. Is this right?
2, that's not right because I didn't show you the E thing. Don't worry about that. We're not gonna have time for
Yes.
continuous interest. E is in the calculator.
Oh, okay.
It's a button, like you just have, like, so what you would do for these ones is you take your principal, and you see how it's E? The E button's about, and then you would raise it to the rate times time.
Okay.
E is like a exponential coefficient that we're not gonna
Wait,
talk
wait,
about.
did you do that, 132.5?
For one of them, semi.
Why would they do that?
What did you guys do? Semicircle.
Example 5?
Something that
For
could
N, for number, for account A, for number
For one of them, it's gonna be two.
I got 16.
The end? For which one?
For account A, you divide
Two.
it by
You know how a semicircle,
You divide
It's
1 by 2
twice
and
a
divide
year.
1 by 365.
because you know how a semicircle is a half of a
What?
circle? If
No,
something
a
happens
year
semi-annually,
is
it means it happens
Or it says,
Daily.
half year.
Daily
which
is
happens twice a
so
year.
it is 6, it's the month.
Oh
my god. Oh wait, I only got the first one.
I'm done. Wait.
Wait, it's the same amount.
You do it after 2 months. What's it?
Nobody listening to me.
So that would one, it looks like for account A and B for labeling. Notice how the principal, guys, if you're comparing two things, when you go to the bank, you're gonna compare the same amount of money you would invest in the same amount of time so you can see which one gets you more dollars. Is that a hand or a stretch?
Oh, so it's 2.
A semi-annual is 2. A semicircle is a half of a circle, so if something happens semi-annually, it happens every half year. If something happens every half year, it happens twice a year. And now we plug in.
What?
My marker is dying, my pen is dying, so this is getting a little sloppy. I apologize.
She's just starting with the meat tool. Here, I need to, here,
It's 365 times 6. What was it? 210. So if you're following along at home, that's what they should look like once you plug them in. And then obviously you have to like crank them into the calculator and get a number so that like you know which amount's going to be more. Now also if I told you that in 6 years you could make an extra $800, I don't know many people that would just like willfully turn it down because they didn't want to check something. And like I said guys, I don't necessarily expect you to remember this going into your adult life where you're like, wow, I remember that compound interest formula. This would be something that you could realistically look up a calculator on, plug all your values into the calculator, and it'll spit out the numbers that we get when we physically like calculate them so that you can make the best decision for yourself. Because obviously, more money is better. So I'm gonna.
Is that slide or
For what?
9,300.
Yes.
1 plus 0.0895 divided by 365. All that to the 2,190. So, look, should I go with account B if I want $16,000?
no?
Are you looking at the number? That's 0.0. So account B only gives me $15,910. Now I gotta check what account A gives me. 9300 1 plus 126 2 Guys, notice the difference again. If you wanted to spoil your kid and you're like, you know what, I can put this money down and not have to worry about it later. Going from $9,300 to almost 16, and it actually for account A is $16,000. It's a way to make some extra money without having to physically put in some work. So again, we would go with account A. I'm going to spare myself having to write it down. $16,008.76.